Hi, my name is Bruno Belanger. I'm the president of Bcomtesting Incorporated. Today I will demonstrate how to do a D3039 tensile testing and determine the Poisson's ratio. Basically, what we have to do for Poisson's ratio is we have to determine the strain in both the Y and X axis. And to do so, we're going to use a C2A gauge with 125,000 grid length. In this case, this is a T-rosette 090, which is basically what we need to do the Poisson's ratio. Why? We can also use a 250,000 gauge, but in this case, the 125,000 is actually what we've used for this material for a long time, so we're very comfortable with this size gauge. To determine the Poisson's ratio, we have to make sure that the grips are well aligned, and we already have taken care of that already. In the standards, there's actually a section to show you how to align the grips. We have done this. Also, you have to pre-calibrate your amplifiers. In this case, we're using micro measurement 2300 amplifiers, and these amplifiers will allow you to go to 30,000 microstrain, which is more than plenty of what we need to do this test. Now I will basically load the specimen, auto balance, and zero out all the offsets, and then run the test. When you actually load the specimen, it's very critical that one is well aligned within the grips, and also that the gripping pressure is very uniform. You need to make sure that your connections are correct. So the transverse on this grid is on the left side, and the axial is on the right side. Now, like I said, I have to basically auto balance and remove the offsets from the strain gauges. And normally we try to be within 0 to 5 microstrain. And if you have a little bit more, you just have to trim the excess off, be within that range. When you find the range to be acceptable for your test, you can now start it. We're going to auto balance the load, and also make sure that my extension is at 0, and I will start the test. You can see now on the curve that you have a very linear displacement and load because we're within the elastic portion. This is where we want to be to determine the Poisson's ratio. We're going to run the test up to 500 pounds. Since we're just trying to determine the Poisson's ratio, we don't need to go to failure in this case. When you reach 500 pounds, you can now stop the test, beginning there. Basically what we've done in this case, we already have pre-run the same coupons 3 times. And if you look at the modulus, we're within what we found acceptable for this product, which is around 3.6 million and 0.14 for Poisson's ratio. The one thing that we've done also, part of the software, we already taken into account the transverse sensitivity. That's really important for composite materials. So you basically, in some cases, you have to deduct the transverse sensitivity. The material is actually moving quite fast. It's not like a steel or a metal or aluminum where we'll have a different transverse sensitivity. With composite and polymers, you have to take that into account. That has been taken care of within the software. This is basically in a very short amount of time how you run a Poisson's ratio test using a tier element rosette strain gauge connected to a universal testing frame. If you have any more questions about testing materials, composite materials, feel free to contact us at Bcomtesting, or you can visit us on our website at www.bcomtesting.com. Thank you.